this is JuiceWorks here. We got a little scenario under the tractor. You can see that we got this steering column here that comes through the bottom of the tractor, and it is normally kept in place from sliding around and being sloppy like this by this this spacer, which the rod goes through here. You can see that it's worn out big time from 12 years of steering here. So pretty simple part here, and we're going to try and 3D print this bad boy to fit right back up in here. Let's see what happens. Alright, so here we are in front of the trusty laptop. You can see the bushing or spacer, whatever you want to call it. This thing's machined. But when you look at the geometry, that's really where the geometry teachable moment is, if you will, where we've got some basic shapes here. What do we see? We've got a circle and we've got a polygon, so we'll count the sides. 1, 2, 3, 4, 5, 6. So we got a hexagon there, and then we have another circle. Anybody spot the other circle? Well, it's actually the hole. And you can see that this is damaged badly. So we're going to recreate that in Autodesk Fusion, which is free. So recreating this in Autodesk Fusion, we came out with something that looks like this. You can see our first circle. So we basically just use the sketch command right here. And we chose sketch circle. We always like to use center diameter circles just because it makes it easy to place them. So we placed that on the grid. We measured the diameter of that circle. So again, we have to use a handy tool called a dial caliper. This is a simple one you can get at Harbor Freight. You take that and measure your diameter, and then apply that to your sketch. Then we draw the polygon on top of that, and then add another circle, and we extrude. So in each of these cases, you actually have 3 shapes that are sketched in 2 dimensions, and then what's called extruded to give it a 3-dimensional, make it pop out of the screen, if you will. So here's the first circle, extruded up however much our measurement indicated to extrude it up. So in our case, it was 0.35 inches upward. Then we drew the polygon in 2 dimensions, extruded that up by 0.15 inches. Then we drew this circle and extruded it through the entire depth of this model to give us that hole, and that's our shape. So we're going to go ahead and bring this thing to the 3D printer. We're going to print it in a material that withstands heat and has good mechanical properties called copoly. Alright, so here we are. We've imported our STL file from the Fusion 360 into our 3D printing program, which is the Prusa Slicer. You can use any slicer software. Then we export the G-code, which you can see right there. It'll take 34 minutes. And here we are doing our thing, getting ready to print. So after half an hour, we'll check out and see how it does. Alright, so 34 minutes later, here's the print. Turned out great. So we're going to take it off the plate and compare it to the original. You can see here's the 3D printed version. Here's the damaged original. You can really see the difference between the printed one and the original. But as far as size, I mean, if we look here, you look at the heights, I mean, they are bang on. And if you flip them over and compare them this way, you can see these are identical. So here we are. It fit like a champ. First time in. Look at this thing. Now we have even spacing. And this steering wheel column is not bouncing around. 3D printing, additive manufacturing at its best, baby.